Hi, I'm Nick Michael. This is my recording for the extra credit assignment, and I've never done anything like this before, so let's hope it goes well. Um, my first week and first few problems, I guess, are going to be pretty straightforward. We'll go over what I learned and the challenges in them. This one was very straightforward. It was just take some inputs and divide them. I did learn what that double division operator does. It takes a division without any remainders. I had no idea that that even existed before I started this. So another one from week one is this if-else statement. It's another pretty straightforward one. I do not know what all these imports are from here. I probably just copy and pasted that in from Python because I definitely didn't use all that. Anyways, in this one, I had to put an output based on some constraints of the input number given. So I take the input. If it's an odd number, the n modular 2 not equals 0 means it's an odd number, because if it divides by 2 and has a remainder, it's going to be odd, weird. Else if it's between 2 and 5, which, I mean, that's what the instructions say, but personally I think it should be 2 and 4, because if it's 5, it's already going to get picked up in the first if statement. Otherwise, if it's between 6 and 20, print weird, else not weird. Fairly straightforward thing. I think the third and final week one assignment, I guess, code problem, deals with loops. This is a pretty simple loop. It takes an input. I set my counting variable to 0 while I is less than the input. Print the square of each number. So this example, it's 3, so 0, 1, and 2, square of 1 is 0, 1 is 1, and 2 is 4. And then at the end of the while statement, count my counting variable. Okay, week 2, write a function. This problem is similar to one of the ones we did in the Python prep course. So that was nice. I was able to look back at that and see what I did. But basically, you get an input of a year, and it return true if it's a leap year, return false if it's not. So I just wrote a function to check the year input. If it's divisible by 4 with no remainder, and the year is not a 100 year like the year 2000 or 1900, return true. Else if it's a modular 400, so we divide by 400 without any remainders, and it is one of those 1900, 2000 years, return true. For everything else, return false. Pretty simple function. Alright, week 2, the second one, compress the string. This one I remember taking me a little while, mostly formatting issues. So with this, you get an input. I'm not sure if you see my cursor, but I'm circling the input over here on the left. You get 1, 2, 2, 2, 3, 1, 1. And you need to output, like 1 here showed up once there, up here in the input, and then 2 shows up 3 times. It's kind of like a set of coordinates. 3 shows up once, and then 1 shows up twice. So for this one, I took the input, turned it into a list, set some counting variables, and then ran a loop to count how many times in a row a number was, and then add that to a list that I'll output later to format. One issue I ran with this problem was that it wasn't appending the last number. I think because in my if statements I was doing x minus 1, so it wasn't finding the last number in the list. So simply adding the append here at the end one last time got that to work. I set my output variable as a string, set a counter, and then loop through to put it in the correct format that it wanted that like coordinates set over there. And that's what took a long time here, was just getting the output to look how HackerRank wanted it to. All right, second week 2 one, string split and join. This one was surprisingly easy, at least I thought so. So all I believe it gave me most of this bottom part here of the code, and it just says, write a function to rip the spaces out of an input string and put dashes in its place. So that's just a simple join. So we take, in the code over here, take the variable that it passes, rip out any spaces, and replace that with dashes. Very straightforward code. Okay, this one, week 3, the first one, triangle quest. This one was tough. It wasn't, I put that in the comments over here. This is a math problem, not a coding problem. It took me forever to figure this one out because I couldn't figure out the math to get what the output wanted. So you have to do this in one line. This top line was given the code. It says more than 2 lines will result in a score of 1. So that's the first line. I have to do the whole thing in one line. Otherwise, I could make a loop and it'd be no problem. But that's not what it wanted. So you get input 5, you have to put 1, the next line 2, 2, next line 3, 3, 3, 4, 4, 4. And if it went further, just keep going for with the n-1 number of lines. With this one, I learned how to do exponents in Python. I'm not sure I've ever done that before. But you have to raise it to, normally if I need to square something, I just take the number times itself, and that's fine. But that would have been awkward in here, and I'm not sure how I would have done it without using more than one line. So I had to make it an exponent and then divide by 9. That was the result of a ton of Googling, like the math problems, to try to figure out how to do this all in one line of code. But, when it worked, it felt really good. So was it worth it? We're going to say yes. All right, week 3, print function. This one was, I think, classified as an easy problem. All it does is takes an input. I set the output as a string, set a counter to 1, and then while this counter is less than or equal to the input number, print the hold on, just look at my code real quick. Oh, I see what it says. Sorry. You just add the new number to the end of std out. So it runs through the first time, it'll just be 1, second time 1, 2, third time 1, 2, 3, and then we take that variable and print it at the end. Not a whole lot to that one. Okay, week 4, word order. So I made the mistake of trying to do a really challenging problem. I actually tried to do this one in week 3, but sunk so much time into it, I was getting close to the deadline, so I did some other ones and turned them in for week 3 and sat on this one for another week. This is what I eventually got working, and I'll show you what I kind of got working next. So this is a weird one. Over here on the left, there's a sample input, 4 and then 3. They call them words, so we're going to call these string of characters words. Then 4 words. You have to, 4 is how many words there's going to be in here, but you have to output how many distinct words are in there, and then how many times each word shows up. So there's 3 distinct words in here. This B, C, D, E, F shows up twice. So the first value here is 2, then 1, 1. So to get this to work, this looks pretty straightforward, but getting there was a challenge. So we declare stdin as a dictionary. I will get to why I'd use dictionaries in a minute. And then just set a loop to get the input data. because it doesn't all come, I guess, discreetly. Well, maybe it does come discreetly. It doesn't all come together. It comes separately. So this just grabs it and appends it to STDIN's dictionary. I had to look up a library and read about it and figure out what I needed from that library to count the instances of the words and then return as a class. So yeah, it returns as a class counter STDIN, and then you get the values equals word dictionary values. So the keys and the values, it gets the values from the dictionary, and then all I want to do is print the values because the key is the counts. Then print the length of the values. That's going to be the distinct word count, because for each iteration or element, I guess you say, each element in the dictionary is one distinct word, and then the count is, for each, if you add up each distinct word, you get the total count. And then the key is the number of times that word shows up in this list that they give us. And then just print it, and I had to do a little formatting here to get to look right. I'd basically just strip out the comma and the open and close brackets at the beginning and the end. This one was arduous. It took me a lot, but I learned a ton about dictionaries and libraries doing it. Now here's what I first wrote: a recursive function to count, basically count all the instances of the words and everything. And this worked. Like, this works. If you take it and run it through with input data, it works. But HackerRank wanted me to do it faster. So for half of the tests that ran through here, this would time out and wouldn't give me a, quote, passing grade. So while this worked, it didn't work at HackerRank standards. And with some help from the professor, I got pointing me in the right direction with dictionaries. I got it to work a lot faster. It's just when it sent in a few hundred words, all that looping and recurring of these functions caused it to time out. But we got there, and that was the last problem that I did. So I hope you enjoyed my presentation.